Okay, so good morning, students. And in last lecture, we have seen that the examination and teaching scheme of engineering chemistry 1. We have seen how the marks is divided into end semester, exam, unit test, and term work. So now we are, and we have discussed about the theory topic that we have 6 modules in engineering chemistry 1, which we have to complete in this semester. So today we are going to start with the small topic of a small module, that is aromaticity. So aromatic system and their molecular structure. So this we are going to start today. Okay, so this is the module. This is small module. We can finish it in 3 to 4 lectures, and then afterwards we will start the water chapter. So students, anyone can tell me what do you mean by aroma? From where this aromatic word has come? So it has come from the word aroma. So do you know the meaning of aroma? Yes, anyone?
Pleasant smell.
Yes, pleasant smell. Yes, very good. So aroma means pleasant smell. So basically the aromatic compounds are considered to be having a sweet pleasant smell. Okay. So from there this word has come, aromatic systems. So these are some prerequisites of this chapter. Just I want to know before starting this topic, how a single bond is formed. Can anyone tell me how a single bond is formed? My question is very simple. That means with how many electrons one single bond is formed? Yes. Yes, students, please tell me the answer. How many electrons are required to form a single bond?
Two.
Two. Yes, very good. Two. So here, this is the one electron, this is another electron, and they both combine together to form a bond. Okay, so these two electrons are required to form a single bond. Two electrons are required to form a single bond. Now, what kind of this bond is? What's the type of this bond? My next question is covalent, yes, because it is formed by sharing of electrons. But whether it is a sigma bond or pi bond?
Sigma.
Sigma bond, yes. So for single bond, we have one sigma bond. So this bond is a sigma bond. Okay, so we know that in a single bond, one sigma bond exists. Okay, is it clear, students?
Yes, ma'am.
Yes. Okay, so this was actually you have already studied in your 10th, 9th, 10th, 11th, 12th, basically. So this was just I was revising because I need this sigma and pi bond I'm going to use again and again in this topic. Okay, now to know that whether you know about sigma and pi bonds, I have again one question. How many sigma and pi bonds are present in this benzene ring? Okay, so before that, you can see here that for one single bond, there is one sigma bond. When there is a double bond, we have one sigma and one pi bond. Okay, so whenever we have a double bond, in that there is one sigma bond and one pi bond. When there is a triple bond between the molecules, then we have one sigma and two pi bonds. Okay, top and bottom are pi bonds and middle one is the sigma bond. So can you tell me now that in this benzene structure, how many sigma and how many pi bonds are present? I have put the question mark on sigma and pi bonds. So let the students tell me how many sigma and pi bonds are present in this benzene ring. Yes.
12.
Yes? Yes, Musab, you are saying something?
12 sigma bond.
How many?
3
Yes,
and sigma bond.
three sigma bonds.
3 pi bond. 12 sigma
Yes,
bond. Sigma bond.
three pi bonds and how many sigma bonds?
12 sigma bonds.
12 sigma bonds. Yes, very good. So there are three pi bonds. As we can see, there are three double bonds into the structure. So based on that, there are three pi bonds because double bond contains one sigma and one pi. So here one pi bond, here one pi bond, here one pi bond. So three pi bonds are there. And sigma bonds are six bonds between the carbon-carbon and six bonds between carbon and hydrogen. So there are 12 sigma bonds and 3 pi bonds. Okay, in the next structure, can anyone tell me how many sigma and how many pi bonds are present? Yes? Next structure, tell me how many sigma and how many pi bonds are present?
15 sigma bonds.
Yes, beta?
14 sigma bonds.
How many sigma bonds?
15.
15. Yes, very good. No, 15. 15 sigma bonds. Yes, and how many pi bonds?
4. 4.
4. Yes, 4 pi bonds. Yes, and roll number 21 EE05. Please mute yourself. It's creating disturbance. Electrical 5. Yes. So in the second structure, we have 4 pi bonds and 15 sigma bonds. Okay, so now you are able to identify how many sigma and pi bonds are present in the molecule. So now we will proceed to our topic, that is aromatic compounds. Okay, so as I told you that aromatic was used to describe some fragrant or sweet smelling compounds in early 19th century. Okay, so earlier the aromatic compound, whenever we used to say aromatic compound, that means that must contain some sweet smell or fragrance in them. Okay, this was the 19th century we used to say that, but it's not basically correct. So later on, it was said that there are many other organic compounds also or aromatic compounds also, but they does not have the fragrance or the sweet smelling. So in that case, they classified it or they grouped it by chemical behavior. So they said that no, we are not going to classify these aromatic compounds based on this sweet smelling nature, but we are going to group by chemical behavior. So chemical behavior means these aromatic compounds, they contain unsaturated compounds. So what do you mean by unsaturation? Yes, students, what do you mean by unsaturation?
Double bond, triple bond.
Yes, very good. The compound contains double bond or triple bond in them. So that kind of compound is known as unsaturated. And saturated means they all only contain single bonds in them. Okay, so unsaturated compounds that undergo substitution rather than addition. So basically we know that unsaturated compounds, they undergo substitution reaction. That's why they said that based on the chemical behavior, we are going to classify these aromatic compounds, and they are nothing but they are unsaturated and they undergo substitution reaction. But again, another this theory came that currently they are going to distinguish aromatic compounds from aliphatic compounds by electronic configuration. they said that there are many chemical behaviors also which does not classify aromaticity and aliphatic compounds. So now we are going to distinguish the aromatic compounds from aliphatic compounds by electronic configuration. Okay, so by using all the three these sentences, we will write its definition as the property of unsaturated cyclic organic compounds, okay, which provide them unusual stability and makes them chemically different from their corresponding open chain or aliphatic compounds is known as aromaticity. तो तीनों सेंटेंस को यहाँ पे इंक्लूड किया है and they have said that they are unsaturated, they are cyclic organic compounds, they have very unusual stability, there means high stability in them, and they are chemically different also, and they are different from the aliphatic compounds also. So aliphatic means open chain compounds, so they are different from them. So this is the definition of aromaticity. क्या है aromaticity? The property of unsaturated cyclic organic compounds which provide them unusual stability and makes them chemically different from their corresponding open chain or cyclic compounds is known as aromaticity. Is it clear, students? So these are certain examples of aromatic compounds. You also have studied in 11th and 12th, benzene, pyridine, pyrrole, thiophene, furan. These are anthracene, okay. So benzene means, you know the structure of benzene, it's a 6-membered compound and containing 3 double bonds in them. They are alternately arranged on the carbon atoms. Pyridine is a 6-membered compound containing 1 nitrogen atom in them. Pyrrole is a 5-membered compound containing nitrogen in them. Thiophene is a 5-membered ring containing sulfur. Similarly, furan, 5-membered ring containing oxygen in them. So these are certain examples of these aromatic compounds. Students, any doubt here? Yes? Do you have any doubt?
No, ma'am.
Okay, so I will continue from here.
Yes.
Now we are going to see the criteria for aromaticity. So what are the criteria which defines the compound as aromatic? Okay, so we are going to consider some criteria and you have to remember these criteria. So first criteria is the molecule must be cyclic. Okay, cyclic means it's a closed ring. Okay, तो आपका a ring form of atoms होना चाहिए. The molecule must be a cyclic compound. Then only it will show aromaticity. The second is the molecule must be planar. Planar means they must have flat structure. So all atoms of the molecule lie in the same plane. Okay, so the molecule must be cyclic, the molecule must be planar, then only they are going to show aromaticity. The third criteria is the molecule must be fully conjugated. What do you mean by conjugated? Can anyone tell me what do you mean by conjugation? I think you have studied in 11th and 12th standard. Yes, beta? Yes, repeat. Yes, students. Tell me what do you know what is conjugation or no?
No, ma'am.
Okay, very good. I will tell you what is conjugation. So I just want to know whether you know the things or not, because in 11th, 12th, many things you have studied. So that's why I'm confirming. Otherwise, if you know the things, then we will move on for next topics. But if you don't know, then please let me know so that I can explain it, because these are the basic things which you should know. Okay.
मैम डबल बॉन्ड के बाद एक और डबल बॉन्ड हो या लोन पेयर हो या पॉजिटिव चार्ज हो नेगेटिव चार्ज हो या फ्री रेडिकल्स को बोलते हैं conjugation.
Conjugation means alternate arrangement of single and double bond. Yes, alternate arrangement of, जैसे benzene ring में है. Benzene ring is a conjugated ring because it contains single and double bonds in alternate way. So here the molecule must be fully conjugated. Okay, so complete conjugation होना चाहिए, and in that case p orbital at every atom will be present, p orbitals. So all the pi orbitals must overlap sidewise. I will show you how these pi orbitals overlap or what are the p orbitals. I will tell you. So you must have studied s, p, d, f orbitals. ये तो पढ़ा होगा आपने.
Yes.
Yes.
Okay. So here I am talking about the p orbitals which are dumbbell shape. You must be remembering the shape, dumbbell shape. So I am talking about that. So whenever the molecule is conjugated or have pi bonds between them, then p orbitals are present at every atom, and all these p orbitals they overlap each other. Okay. The fourth criteria is the molecule must have 4n plus 2 pi electrons. Okay. So what is this 4n plus 2 pi electrons? This is basically a rule which is known as Huckel's rule. Okay. So here we are going to consider Huckel's rule, that the molecule, if we are saying that it is aromatic, then it must satisfy the Huckel's rule. Okay. So here in this Huckel's rule, 4n plus 2, n is integer. Okay, any positive integer from 0, 1, 2, 3, 4, 5. Okay. So any integer we have to take as n. So if you will put here n is equal to 0, then what will be the value? If n is equal to 0, what will be the value?
2.
2. Yes. If n is equal to 1, if n is equal to 1, then
3. 6.
6 better, not 3, 6.
Yeah.
So 1 plus 2. So 4 1 is 4 plus 2 6. Okay. Similarly, if you will put here n is equal to 2, 3, you will get different numbers, and these numbers are known as magic numbers. Okay. So if your compound satisfies these magic numbers, or if they contain the magic number of pi electrons, then that molecule is aromatic in nature. The fifth criteria is it should have a tendency to show resonance forms. Now, resonance also you have studied. Can anyone tell me what is resonance? What is resonance? Delocalization of electrons. Yes, beta. Who was telling? Please tell me. What is resonance? Hello. Am I audible?
Movement of electron for the stability.
Yes, movement of electron to get stability, or delocalization of the electron to make it more stable. Okay. So, and based on this resonance, we get different structures. So here, all the atoms present in the ring must be sp2 hybridized. This is the sixth criteria. So whatever the number of elements are present in the ring, atoms are present in the ring, that must be sp2 hybridized. So these are the 6 criteria which defines aromaticity. So if a molecule or a compound is having or fulfilling all these criteria, then we can consider that compound as aromatic in nature. Okay. So we will see some main 4 the structural properties, that is first, second, third, and fourth criteria. In detail, I will show you how it should be. So first criteria is a molecule must be cyclic. Okay. So how a molecule looks like. So this is the example I have taken here. This is an example of benzene ring. You can see that it is a closed ring. So we can call it as a cyclic compound. Okay. So here in this case, this blue and red, whatever is shown, they are the p orbitals. You know that p orbitals are dumbbell shaped. So it is basically dumbbell shaped p orbitals. Top are blue and bottoms are red. So every p orbital overlaps with two neighboring p orbitals. So if you consider the first, this carbon atom, so here the p orbital is overlapping with other two p orbitals of the neighboring carbon atom. So this is mapping, these are overlapping with this carbon atom and this carbon atom. Similarly, if you consider this carbon atom, it is going to overlap with this and this. Okay, so any carbon atom, if you consider in this ring, they are going to overlap with the neighboring two carbon atoms. So that's why we call it as a aromatic compound. Cyclic compound hai, so it's a aromatic. But here you can see that in this structure also we have 6 carbon atoms. In benzene also we have 6 carbon atoms, and here also we have 6 carbon atoms. But here the first and 6 carbon atom are the terminal carbon atoms. They are not linked together. They are not overlapping with each other. So that's why it's an open chain ring, and we call it as 135 hexatriene, because there are 3 double bonds at first, third and fifth position, okay, in the ring. So the overlapping may take place on these carbon atoms which are joined with each other, but no overlap will be there on this terminal carbon atoms. So first carbon atom and the 6 carbon atom are terminal carbon atoms, and here there will be no overlapping. So that's why it is not forming a cyclic compound. So it's a acyclic compound, and because of that it is not aromatic in nature. Is it clear, students?
Yes, ma'am.
Yes.
Okay. Any doubt here? Any doubt? So this is the first criteria, that molecule must be cyclic. So in this way, it should be a closed ring cyclic compound. Then we will see the next, that is a molecule must be planar. As I told you, it should, the structure of the molecule must be flat, planar hona chahiye. So here again I have taken the example of benzene. So you can see here benzene, it's a planar molecule. All the 6 carbon atoms as well as all the 6 hydrogen atoms, they lie on the same plane. Okay, it's a flat structure. It can be kept on the table properly. So here you can see that each carbon atom is sp2 hybridized, as I have told you. That suppose we have taken the example of this carbon atom. So this carbon atom is overlapping with one hydrogen, so that is s orbital of hydrogen, and these 2p orbitals of the other carbon atoms. So on this side and on this side. So these are the two p orbitals. So it is overlapping, this carbon atom is overlapping with one s orbital of hydrogen and 2p orbitals of the adjacent carbon atoms. So that's why it is sp2 hybridized. Similarly, all the carbon atoms of this benzene ring are sp2 hybridized because all are overlapping with one hydrogen and 2p orbitals of carbon. Okay, so molecule must be planar. So these kind of structure, if we are having of the molecule, then we can say that that molecule or the compound is aromatic in nature. Is it clear? Now we will see the third criteria. So first is, of course, it must be cyclic, it must be a planar structure, and third is what? A molecule must be completely conjugated. Okay, so conjugation, I have already told you what do you mean by conjugation. That means it should, single and double bond should be arranged in alternate way. So here we will take one example. See, again I have taken the example of benzene because it's a simple example from which you can understand the things very clearly. So a completely conjugated ring. Benzene is a completely conjugated ring. You can see the arrangement of double bonds in the benzene ring. It is completely alternate. Double bond, single bond, double bond, single bond, double bond, single bond. Okay. So benzene is a completely conjugated ring. And because of the conjugation, at every carbon atom, we have the p orbitals. So therefore, this is aromatic in nature. Okay, but here on the other side you can see two examples. This is not the benzene ring. Benzene ring contains three double bonds, but here you can see that one bond is missing, so it has become a cyclic uh, compound. Okay, but not aromatic. So here the name of the compound is 1,3-cyclohexadiene. So on first position and on third position we have a double bond. So that's why we are writing 1,3-cyclohexadiene. Carbon atoms are 6. There are two double bonds. So that's why diene, hexa 6. So but here you can see the arrangement of single and double bond is not conjugated completely. Here you can see double bond, double bond, single bond, again single and single bond. So at this place, actually it should be a double bond, but it's not there. It's not present. So there is no p orbital on these two carbon atoms. So because of that, it's a non-aromatic compound. Okay. Similarly, in this compound also, there are 7 carbon atoms. So it is hepta and 3 double bonds, so triene. So at what position the double bonds are present? 1, 3 and 5. So 1, 3, 5 cyclohexatriene. But here you can see that these carbon, the arrangement of the double bond and single bond is again not completely conjugated, and you can see that this carbon atom is not having any double bond. So that means it is not containing any p orbital for the overlap. So this compound is also a non-aromatic compound. Okay, so completely conjugated hai, then only the compound is aromatic in nature. Is it clear?
Yes, ma'am.
Yes, students. Okay, now fourth one is a molecule must satisfy Huckel's rule. As I told you that what is Huckel's rule? 4n plus 2. So a molecule must satisfy this Huckel's rule and contain a particular number of pi electrons. Okay, so a particular number of pi electrons should be present. That is magic number of electrons, which we have already discussed. So a molecule must satisfy this rule. Then only it will be a aromatic. So we here also we will see some examples here. So first we will see what is Huckel's rule. It's an aromatic compound must contain 4n plus 2 pi electrons where n is an integer number. 0, 1, 2, 3, 4, 5. This is nothing but this is Huckel's rule. Okay. So benzene is aromatic and spatially stable because it contains 6 pi electrons. आप बेंजीन में देखिए यहाँ पे कितने पाई इलेक्ट्रॉन्स हैं, पाई बॉन्ड्स कितने हैं, 3 है ना, और एक पाई बॉन्ड को बनाने के लिए कितने इलेक्ट्रॉन्स लगते हैं, 2. सो टोटल देयर आर 6 पाई इलेक्ट्रॉन्स. ओके, तो आप इसके अंदर अगर 4n is equal to 1 डालते हो, so you will get 6 pi electrons. So this number satisfies the aromaticity. But cyclobutadiene is non-aromatic and especially unstable because it contains 4 pi electrons. So here I will show you the example. So this is the benzene, which we are saying that it is an aromatic compound because it has 6 pi electrons in it. But here you can see the cyclobutane. Okay, here 3 criteria are satisfied. Kaun sa? Is the molecule is cyclic? Yes, students, tell me the answer.
Yes.
Is it planar? Is it planar?
Yes.
It's planar structure. Then is it completely conjugated ring?
Yes.
Yes.
Yes, it is completely conjugated. You can see the alternate arrangement of double bond, single bond, double bond, single bond. Okay. And whether it satisfies Huckel's rule? Whether it satisfies Huckel's rule?
No.
No. Why no? Because how many pi bonds are present here? There are 2 pi bonds. And
2 pi bonds.
pi bonds, we have 4 pi electrons. Okay. So 4 pi electrons does not fit into this rule 4n plus 2. अगर आप ये 0 भी लेते हो, n is equal to 0 here in this formula, then it becomes 2 electrons, not 4. So that's why this compound satisfies the three main rules but does not satisfy the fourth one. So because of that it is not aromatic in nature. Okay, तो हमको कोई भी अगर कंपाउंड आपको एग्जांपल दिया है and you have to find out that whether that compound is aromatic or not, then you should think these four questions. You have to ask yourself these four questions: whether the molecule is uh, cyclic in nature, whether the molecule is planar, having planar structure, whether the molecule is completely conjugated, and whether the molecule satisfies the Huckel's rule, that is 4n+2 rule. If they satisfy all these four criteria, then that compound is aromatic in nature. Otherwise, it's non-aromatic. Is it clear, students? Any doubt? Yes, students? See, you
Clear,
are
ma'am.
not, yes, you are not sitting in front of me so that we can read your faces and we will come to know that, okay, these people are getting everything or not getting anything. So you are in online mode, so you must have to give the responses, then only I will come to know that you are getting it or not. Otherwise, what I will consider that you have studied in 11th and 12th, so I will proceed further. So unless and until you will not tell me that or explain again, or I am not getting any getting something, then I will not come to know that you are getting the things, understanding the things or not. Okay. तो अगर आप सामने होते क्लास में तो मैं आपको पूछे बिना आपके फेस देख के मैं आपको बता सकती थी कि आपको समझ में आ रहा है या नहीं आ रहा है. But here this situation is not that. Okay, so please students, if you don't understand anything, please let me know so that I can explain again. Okay, so we have seen that the four important criteria for becoming the aromatic compound. Now we will see in detail what is Huckel's rule, because this question can be asked in exam. Define Huckel's rule with some example. So Huckel's rule is nothing but 4n+2 pi electrons. Okay, and where n is an integer 0, 1, 2, 3, 4, 5. So according to this rule, the cyclic unsaturated compounds containing 4n+2 delocalized electrons or pi electrons exhibit aromatic nature. So any compound, any unsaturated compound or cyclic in nature, having planar structure, having conjugation in them, if it satisfies 4n+2 pi electrons, or then it can exhibit aromatic nature. Okay, so n is your integer, and if you put the value of n is equal to 0, we get 2 pi electrons. If n is equal to 1, it is 6. If n is equal to 2, it will come as 10 pi electrons. If n is equal to 3, then 14. N is equal to 4, then 18. 5, 22. So in this way, you can increase the number of an integer value, and you can find out the magic numbers. So these are the magic numbers: 2, 6, 10, 14, 18, 22. So if the compound shows these magic numbers, then that compound can show the aromatic nature. Okay. इसमें आपने 5 डाला, so 4 5 are 20 plus 2 22. For example, I have shown. क्या बेटा, कुछ बच्चे बार बार बाहर जा रहे आ रहे. Okay. So now here, therefore, according to Huckel's rule of aromaticity, an aromatic compound is the unsaturated cyclic system containing these magic numbers, that is 2, 4, 6, 10, 14, 18, 22 number of pi electrons or delocalized pi electrons. Okay. Any doubt here in Huckel's rule?
No, ma'am.
Is my voice clear?
Yes, ma'am.
Okay, thank you so much. Okay, so we will proceed further. Okay, aromaticity and 4n+2 rule. We are going to say, just I am revising actually, that based on the calculations, a compound is aromatic if it is a Can you tell the answer? If it is a planar, if it is cyclic, and if it is having alternate double and single bond, that is conjugation, and follows 4n plus 2 pi electrons. So the compound is aromatic if they satisfies these four main criteria. It must be cyclic, planar, alternate double and single bonds, and has 4n plus 2 pi electrons. Okay, so here I am taking the example of benzene. So benzene, you can see there are three double bonds. It is shown in pink color. So because of these three double bonds, we have 6 pi electrons present in them. So if you put n is equal to 1, it comes to 6. So benzene is stable and electrons are delocalized. They are alternate double and single bonds. Their structure is planar. It's a cyclic molecule. Therefore, it is an aromatic compound. बेटा आपका स्लाइड चेंज हो रहा है क्या?
Yes.
Okay. Okay, now we are going to see another example, aromaticity in cyclopropynyl cation. Okay, so this is again a compound which I have taken here. This is the structure of this compound, cyclopropynyl cation. Okay, so whether this first question will be whether it is a cyclic. Yes, it's a cyclic compound. It has planar structure. Yes, it has planar structure. Whether it is having alternate double and single bonds. Yes, students, tell me whether it has alternate single and double bonds.
No.
No. Okay. You cannot see alternate and single and double bond, but I will tell you afterwards. But still, this compound is aromatic in nature. Okay, how it is aromatic in nature? Because it shows resonance structures. Because the this double bond this double bond pi electrons which are present here in the molecule, it can be delocalized on other carbon atoms. Okay, so that I will explain you again. And whether it can satisfies 4n plus 2 rule. Yes. How many pi electrons are present in this?
2.
2. तो 2 है ना, मैजिक नंबर है ना?
Yes.
यस, तो आपका 3 क्राइटेरिया तो यहाँ डायरेक्ट सेटिस्फाई हो रहा है. साइक्लिक है मॉलिक्यूल, प्लेनर स्ट्रक्चर है, आपका वो 4n plus 2 शो कर रहा है, 2 इलेक्ट्रॉन्स है. सिर्फ आपको थोड़ा डाउट यहाँ पे क्या है, दैट देयर इज नो अल्टरनेट सिंगल एंड डबल बॉन्ड्स, बट दैट कैन बी क्लियर्ड विद द हेल्प ऑफ रेजोनेंस स्ट्रक्चर्स. तो यहाँ पे जो आपका कार्बन एटम है पॉजिटिव कैटायन है, so this cation is basically it is having the electron deficient. This carbon is electron deficient. Okay, so these two electrons can move from this place to here and satisfy the carbon atom of this. Similarly, this double bond can again shift to here to satisfy the carbon atom at this place. So we will have to see the resonance structure. So resonance structure means delocalization of bond. So this 3-membered cyclic compound है. Okay, molecular formula इसका है C3H4 plus. It's a cyclic compound and structure. It shows delocalization of pi electrons and propynyl cation is also an aromatic compound. Okay, understood, students? Any doubt here? Yes, students, am I audible?
Yes, ma'am.
Hello. Okay.
Yes, ma'am.
So is there any doubt here? Other 3 criteria are easily satisfied here. Only one, that is alternate double and single bond, that is conjugation, is not clear here. It is satisfied, but it is not clear. because this compound shows delocalization of pi electron that I will explain you in further slides. Okay, but this compound is aromatic in nature. Okay, so here you can see that how the resonance contribution helps the molecule to become aromatic. So here you can see I have taken all the three examples, that is cyclopropene, cyclopropynyl cation, cyclopropynyl anion also I have taken. But out of these three structures, cyclopropene and cyclopropynyl anion are not aromatic in nature. Only this cyclopropynyl cation is uh, aromatic in nature. Okay, but all this satisfies other three rules. आपका ये तीन रूल सेटिस्फाई कर रहा है. कौन सा? साइक्लिक है तीनों, आपका प्लेनर भी है, आपका 4n+2 भी सेटिस्फाई कर रहा है, लेकिन आपका ये नॉन एरोमेटिक है. क्यों? बिकॉज ऑफ देयर इज नो delocalization of electron here, and here there are 4 pi electrons. ये 2 electron and these 2 electrons are also extra on this carbon atom. So there are 4 pi electrons on this ring. So that means it is not aromatic, which does not fit into the 4n+2 pi electron rule. But here you can see that in case of cyclopropynyl cation, the resonance contribution of the compound. So here you can see, as I was telling you, that this double bond, that is pi electrons, can shift from this place to satisfy this carbon atom, because this carbon atom is electron deficient. उसके पास electrons नहीं है, तो उसको stable बनाने के लिए ये आपका 2 pi electron move कर रहा है easily. तो यहाँ से यहाँ मूव करेगा इस पोजीशन पे, यहाँ पे डबल बॉन्ड बन जाएगा और ये वाला आपका कार्बन एटम पॉजिटिव हो जाएगा. सिमिलरली अगेन this bond can move to this place to satisfy this carbon atom, and there will be here positive carbon atom. Okay, so in this way there are three structural contribution, resonance contribution, and because of that we can see that this is a resonance hybrid structure of this cyclopropynyl cation. Okay, so here you can see the dotted line in the structure, and this dotted line shows that the positive charge is not fixed on any one single carbon atom. It can be on any 3 carbon atoms. Or it also shows that the pi electrons which are there, those pi electrons are not only considered at one position, but it can move into the ring at any position. जैसे हम लोग बेंजीन रिंग लिखते हैं, तो बेंजीन रिंग में हम लोग बीच में सर्कल डालते हैं ना. Yes, students, do you remember the structure of benzene?
Yes, ma'am.
We put a circle in the center. So why we put that circle in the center? Because there it is considered that it shows resonance, and the pi electrons which are there into that 6 pi electrons, they can all move to 6 carbon atoms. They are not fixed to any 3 carbon atoms, but they can move from one place to another to all the 6 carbon atoms, and all the 6 carbon atoms are equal. वहां पे 6 कार्बन एटम्स जो है वो सारे के सारे आपके इक्वल्स है. There is no fixed position of the carbon atoms there. So that's why we put the hybrid form, that is circle at the center. Okay, so this here also, because of the resonance structures, we are putting this dotted line, and it shows that it is a resonance hybrid structure. Is it clear, students? Cyclopropynyl cation is aromatic in nature. इरफान शेख, इलेक्ट्रिकल 0A.
Yes, ma'am.
हाँ बेटा, बताइए, व्हाट आर द 4 क्राइटेरिया?
Cyclopropene,
साइक्लिक, यस.
chlorophenyl cation,
हाँ, क्या बोल रहे हो बेटा?
chlorophenyl cation,
साइक्लोप्रोपेनल कैटायन नहीं ना बेटा, मैं पूछ रही हूँ किसी भी कंपाउंड को एरोमेटिक होने के लिए जो 4 क्राइटेरिया है, वो 4 क्राइटेरिया बताओ. Don't take any example. Just tell me all the 4 criteria.
Yeah, ma'am. First is cyclic. Second is
Yes.
4n plus 2.
Yes. Third.
Let's see.
Yes, anyone else who can say all the 4 criteria?
Follow conjugate rule.
Yes,
fully
beta?
conjugated.
Fully conjugated, yes. And the fourth?
Planar.
Must be have form
Planar
and
structure. Yes, so 4 criteria are: the molecule must be cyclic, it must be a planar structure, it must satisfy the Huckel's rule, 4n plus 2 pi electrons, and it must be conjugated. Okay, so these are the 4 criteria to have the aromaticity in any compound. Okay, now we'll see some examples of aromatic and non-aromatic compounds. So these are examples of some aromatic compounds and these are the non-aromatic compounds. तो आपने देखा साइक्लोप्रोपिनाइल कैटायन है, यहाँ पे साइक्लोपेंटिनाइल एनायन है, साइक्लोहेप्टेनाइल कैटायन है. Okay, these all are your aromatic compound. They satisfy all the 4 criteria. But these compounds, they satisfy some criteria but not satisfy all the criteria. So they are non-aromatic in nature. Okay, this topic we are going to study tomorrow. So I'm stopping the screen share and let me take the attendance. Okay. So now you can tell me your attendance. Just a minute.